Hi guys, welcome to my YouTube channel. In this video, I'll walk you through how to perform image classification with KERAS. To show this, I'm going to use Collab. To use GPU, let me choose GPU. After that, click on Save Bottom. Cool, we can implement deep learning analysis on GPU. Next, let's connect the Collab notebook. Okay, we are ready to analyze. KERAS is a deep learning API, written in Python, running on top of the machine learning platform TensorFlow. To work with KERAS, let's import TensorFlow. Let me write import TensorFlow as TF. Okay, we imported TensorFlow. The dataset we're going to use is the Fashion MNIST dataset. This dataset consists of a training set of 60,000 examples and a test set of 10,000 examples. Each example is a 28:28 grayscale image associated with a label from 10 classes. Let's load this dataset with KERAS. Let me write fashionMNIST equals tf.keras. Let me set the name of the dataset. And lastly, let's type load data method. Cool, we loaded the dataset. Let's now perform data preprocessing. What I'm going to first do is split the dataset into training and test sets. To do this, let's write training set, strain, train. Next, let's write test sets, stest, itest, equals, and let's type the variable, fashionMNIST. Nice, we created the training and test sets. You can build your model with the training set, and then you can evaluate this model with the test set. The images in the dataset consist of pixels between 0 and 255. Let's scale these values between 0 and 1. By doing this, we train our model faster and more accurately. Let's write the input datasets, strain, stest, equals, strain/255. Stest/255. Cool, we scaled the datasets. Note that the dataset consists of fashion objects. Let's create a variable containing these objects. Let's write a variable name, class names, equals, and let's paste fashion objects here. Let's go ahead and take a look at the first label using this variable. Let's write class names and then train 0. Here, you can see the label of this sample. Cool, so far, we loaded our dataset, and then split the dataset into the training and test sets. Lastly, we scaled the datasets. Our datasets are ready to train the model. Let's move on to training the model. In this section, we're going to build a deep neural network for image classification. The easiest way to do this is to use the KERAS sequential API. Let me show you how to do this. First, to make the results reproducible, let's use the setSeed method. Let's type tf.random and then write setSeed. Pass 42. After that, let's create a sequential model. To do this, let's write model equals, let's call sequential class, tf.keras sequential. Next, let's add a flatten layer. This layer converts each input image into a 1D array. Let's write tf.keras.layers flatten. Let's pass input shape equals 28:28. Cool, we added the first layer. Let's now add a hidden layer. To do this, we're going to use the dense layer. Let's write tf.keras.layers dense. Next, specify the number of neurons, let's give 300. Note that you need to determine this number according to your problem. After that, let's specify the activation function. The activation function converts the inputs into output by applying a transformation. The most used activation function is ReLU. Let's pass this function, ReLU. Okay, we added the first hidden layer. Let's go ahead and add another hidden layer. We're going to add a second dense hidden layer. Let's write tf.keras and then type layers, dense. Let's pass 100 neurons, also using the ReLU activation function. Great, we've added another hidden layer. Finally, we're going to add an output layer. To do this, let's write tf.keras, layers, dense. Since there are 10 classes in the dataset, let's pass 10 neurons per class. After that, let's use the softmax activation function, because the classes are exclusive. Let's write activation equals softmax. Great, we've built our model architecture. We can see this architecture with the summary function. Let me show you this. Let's write model summary. Here you are. Here, you can see all the model's layers, including each layer's name, its output shape, and its number of parameters. Note that, the names of the layers are automatically generated, unless you set them. Here, none means the batch size can be anything. Nice, we've seen our model architecture. Let's move on to compile our model. After creating a model, you need to call the compile method. In this function, you can specify the loss function and the optimizer. Optionally, you can also set a list of extra metrics in this function. Let's do it. First, let's call the compile method. Let's type model.compile. After that, let's specify the loss function. Since we have sparse labels, we're going to use sparse categorical cross-entropy. Let's write loss equals sparse categorical cross-entropy. Next, it's time to determine the optimizer. The optimizer allows the model to perform the backpropagation algorithm. For the optimizer parameter, let's write stochastic gradient descent. Finally, since the problem we deal with is a classification problem, let's use an accuracy metric. To do this, let's write metric equals accuracy. Cool, we compiled our model. Let's move on to train the model. To train our model, we're going to call the fit method. In this method, we're going to use the training set. To do this, let's first create a variable named history. Let's write history equals. After that, let's call the fit method. Let's type model.fit. Next, let's pass the input features, strain, and then the target classes, eTrain. And then, let's set epochs to 30. Finally, to create a validation set, let's use the validation split parameter and give it 0.1. Let's run this command. Cool, training started. At each epoch during training, KERAS displays the accuracy and loss values for validation and training sets. Notice that the training loss went down. That is a good sign. That means that our model is learned from data. Note that the training and validation accuracies increase, while loss values decrease. Cool, as you can see, the validation accuracy reached almost 90% after 30 epochs. That's slightly below the training accuracy. Nice, we trained our model. Let's move on to evaluate our model on the test set. To evaluate our model, we're going to use the test set. To do this, we're going to call the evaluate method. Let's write model.evaluate and then pass the test sets, stest, and itest. The accuracy of our model on the test set is around 88%. This is not bad. You can obtain a better model by fine-tuning the hyperparameters. Let's move on to predict new data. After training a model, you want to make predictions. To do this, we're going to call the predict method. First, let's get some data from the test set. Let's write new equals stest, and let's select the first 3 samples. After that, let's predict the labels of these data. To do this, let's type iproba equals model, let's call predict, and pass the new variable. Cool, we made predictions. Let's take a look at these predictions. Let's write iproba. Let's call the round method, and then pass 2 to it. As you can see, for each instance, the model predicted 1 probability per class, from class 0 to class 9. We can see the labels of the highest predictions, using the argmax method in number_py. To do this, let's import number_py first. Let's write import number_py as np. After that, to get the highest prediction, let's use the argmax method. Let's write iperd equals iproba, let's call the argmax method, and then pass axis equals -1. Let's take a look at this variable. Let's type iperd. Here, you can see the classes of 3 samples. We can also look at the labels corresponding to these classes. To do this, let's write np.array. Let's set class names. Pass iperd. Here, you can see the labels. Let's compare these labels with real labels. Let's write inu equals itest. Let's set 3. Let's look at this variable. Let's type inu. Bingo! As you can see, our model correctly classified all 3 images. That's it. In this video, you learned how to use the sequential API to build, train, and evaluate for image classification. Thanks for watching. I hope you enjoy it. Don't forget to subscribe to the channel and hit the bell icon so you don't miss the latest content about AI and data science. You can also follow us on other social media accounts. You can find the links in the comments. See you in the next video. Bye for now.